Why shouldn't I use standard thermocouples to measure temperatures on a high voltage battery? What is actually so dramatic about this high voltage? And why should I laboriously adapt my expensive measuring equipment just because we are now doing e-mobility? These are questions that we have been asked in the past by people who were used to working with voltages of 12, 24, or even 48 volts in the world of combustion engines. People who measured variables such as pressure, strains, vibration, and temperatures, or simply current and voltage as part of their projects and activities. People who have suddenly found themselves sometimes overnight in electromobility, for example, because their companies decided we are now doing electromobility. Well, we humans are creatures of habit, and we rightly ask ourselves, why should I change anything now? Are there any good reasons for doing so? However, there's one more question we should always ask ourselves, and that is the following question. What is the worst that can happen if I don't change anything? If I just carry on as before? Well, in the case of measurement technology in high voltage applications, quite a lot might happen if we do not adapt our measuring equipment to higher system voltages, ranging from a simple voltage flashover and a broken sensor to a vehicle fire or even a fatal electric shock. In today's episode of CSM Explained, we want to talk about these dangers and, of course, ways and means of countering them. We will familiarize you with the relevant standards and guidelines and show you practical application scenarios. We will also show you specific products and solutions that will ensure you are always on the safe side when collecting data in a high voltage environment. And to this end, we are also introducing you today to one of our most important partners when it comes to safe and practical solutions for the electromobility, namely the cable specialists from SAB Bröckskes, represented today by Kilian Ingrid, Sales Manager for High Voltage Measurement Technology and Cable Assembly. Hello, Kilian.
Hi, Timo. Thank you very much for the invitation. My name is Kilian, and I'm very excited for talking to you about high voltage safe sensor cables today.
Kilian, you're welcome. I would also like to introduce briefly myself to you, dear viewers. My name is Timo Eich. I am Business Development Manager at CSM, and today I'm your tour guide through the literally exciting world of analog measurement technology in the context of e-mobility. Today we will proceed as follows. I will tell you a bit about the framework conditions for measuring under high voltage conditions. We will then take a close look at the complete measurement chain from the sensor to data acquisition from the point of view of high voltage safe measurement. And this is where our guest speaker Kilian will take over when it comes to sensors, cables, and connector solutions. I will then take over again at the transition to measurement technology hardware, and at the end, after a short break, we will have a Q&A session for you. Sounds good to you? Great, then let's go. And we will start with something you may be very likely be familiar with, a comparison of the different components. Here, conventional vehicles on the left side versus electric vehicles on the right. In combustion engine vehicles, most of the drive components, but also heating and air conditioning functions are mechanically based. The energy storage is the fuel tank of our combustion engine, and commonly the electric system voltage lies at 12 volts for smaller vehicles, 24 volts for larger vehicles such as trucks, and sometimes 48 volts for steering functions or mild hybrid features, for example. The point is that we never exceed 60 volt system voltage, and this border of 60 volts will be important in a moment. On the right side, we see that nearly all of the mentioned components of the drive and also the HVAC system of electric vehicles have been electrified. They are totally new components. The energy is supplied and stored in a high voltage battery. Thus, we are now operating our vehicle systems mainly with 400 volts and far above, sometimes up to 1000 volts today. That means that we exceed the magic border of 60 volts tremendously. So why is that a problem? To answer that question, let's take a look at some norms and regulations. In Germany, for example, the safety extra low voltage is up to 60 volt DC, but only in dry environments. In most environments, only 35 volts. Now, the norm IEC 61010 declares that all voltages beyond the safety extra low voltage have to be handled with extra care, meaning that additional insulation and safety measures have to be taken. This is extremely important to protect personnel from possibly fatal electric shock. And in other countries, we find similar regulations, such as the OSHA 29 in the US, which already demands additional safety measures beyond 50 volts. What does that mean in the context of test and measurement? It means that we must take additional requirements for our measurement equipment into account. So when we want to choose appropriate measurement technology for a measurement task, certain questions should be asked always. What is the application scenario? Where are we going to measure? How many channels with which sampling rate and which bandwidths are we going to need? What are the climatic conditions? Which degree of pollution will our measurement equipment experience? And now, if we are measuring in electric vehicles, what is the operating voltage of the vehicle? Are we going to need special high voltage safe equipment? Well, for better understanding, let's take a look at an example of temperature measurement. Let's assume that we want to measure temperatures inside of the high voltage power electronic systems of an electric car. And let's also pretend that we would be intending to use our common measurement technology we always used on combustion vehicles, for example, some THMM8 modules from CSM with standard SAB thermocouples, utilizing the good old green thermal connectors. Unfortunately, by doing so, we immediately experience severe issues concerning the safety of our measurement. Firstly, if we just feed multiple thermocouples through a cable gland, we will not have sufficient strain relief for those. The cable gland is not likely to be waterproof, what however would be vital for the power electronics inside of the box. The standard thermocouples themselves only provide insufficient insulation. They are not high voltage safe. And finally, the beloved green thermoconnectors provide no contact safety, with their contacts here lying free. All summed up results in a literally dangerous measurement chain, and using such in an HV environment could lead to severe consequences, and not only technically wise, but there could also be legal consequences. By putting investments like prototypes, test devices, or measurement technology, and above all, human health at stake, you risk being prosecuted in the case of personal injury. As the person in charge of safety, it is your job to prevent your company and your colleagues from harm due to not suitable measurement technology solutions. And if you don't, you can come into conflict with the law, namely liability law, employment law, civil law, and finally criminal law. Now, to prevent all these inconveniences, it is key to opt for suitable, appropriately certified and high voltage safe measurement technology. So let's take a look at which requirements a corresponding measurement technology must meet. Generally speaking, we need certified safety from the measuring point to data acquisition. We need a touch-proof and insulated overall system that can be installed directly in the hot areas close to the points of measurement, and which is suitable for both mobile applications and test benches. We need a special color coding. For instance, the EN 61010 norm demands a special color, RAL 2003, for all possibly high voltage leading assemblies. a special orange color. And of course, we want precise and reliable measurement results as well as convenient and safe handling. And all of those requirements lead to seamless operating and operational safety from the measuring point to data acquisition. And one very important aspect here is that our measurement technology must never lever out the vehicle safety concept. What does that mean? The vehicle manufacturer strictly separates the high voltage electrical systems and from the systems operating with 12, 24 or 48 volts as well as the vehicle body. If we now install measurement technology into this vehicle, our measurement technology must never become an electric bridge, allowing the high voltage to propagate into the low voltage areas. This is also declared in several regulations, for example, the ISO 64493. Thus, we need special measures with our measurement technology to prevent high voltage to do not get somewhere it should not be. And now I want to present you how we at CSM establish certified safety, certified high voltage safety, namely with our CSM safety concept according to EN 61010. In this schematic, imagine you can see a high voltage area on the left side represented by a high voltage battery, and on the right side you see a laptop computer for the data acquisition purposes. And on the border of those two areas, you can find a CSM measurement module, for example, for temperature measurement. And you can see an orange signal cable leading out of the battery connected to our high voltage measurement module. This is a high voltage safe signal cable, which allows the use of standard sensors inside of high voltage environment to protect both equipment and personnel. The sensor inside of the battery may be installed isolated, for instance, using isolating temperature conducting Kapton adhesive tape, or, and that is quite often reality, the sensor is attached without isolation. Although now high voltage potentials may be led by the signal cable into the high voltage measurement module, the module itself provides a reinforced galvanic insulation of 1000 volts RMS for each channel. And by those means, our measurement module prevents high voltage crossing over into the low voltage area. Now, in the next minutes, we will look at the whole high voltage safe signal chain in more detail, starting with sensors and cables and ending with data acquisition. And this is perfect timing to hand over the word to our guest speaker from SAB. Kilian, the stage is yours.
Thank you, Timo. Thank you for the introduction. Yeah, before we start with high voltage safe sensor cables, I want to take the chance to briefly introduce you in our company SAB. We are a medium-sized company managed by family Bröckskes in third generation. Our today's CEO is Sabine Bröckskes-Wetten. Our headquarters in Viersen is close to Düsseldorf and the border to the Netherlands. We also have international subsidiaries in New Jersey, USA, Shanghai, China, France, and the Netherlands. We are specialized in developing and producing special cables, as for high flexible applications like robots, or the reason why I'm talking to you today, sensor cables. So let's dive into our main topic, high voltage safe sensor cables. On this slide, you can see a quite typical illustration of our high voltage sensor cables. There are two parts of a sensor cable we need to get safe to get a high voltage safe sensor cable, the connector and the cable. Let's start with the cable. Now you can see different types of our high voltage cables. On the left side, a PT100 cable. On the right side, three different types of Type K cables. Today, I will not talk that much about the differences. These are mainly important for the application in different components and to get best measurement solution, but less for the safeness. Let's have a look on the similarities. First of all, These cables have an orange outer shell and a stripe. The orange color is signalizing high voltage environment. The stripe shows you that these cables are measurement cables. As thermocouples have a color code, and the code for type K is green, these cables have a green stripe. Over the outer shell, our high voltage sensor cables are at 1000 volts safe to touch. To ensure this, we have a warning inner blue shell underneath our orange outer shell. Now I want you to show some examples of high voltage safe sensor cables for CSM modules. Except for the temperature sensors we saw before, we have also connection solutions for maybe acceleration, IPE, and stain gauges. Let's come back to the measurement chain Timo showed us before. Now we are going out of the component with a strain relief, so it is waterproof, and use one of our high voltage safe cables. But from sensor cable side, there is still a dangerous part, the connector, especially as the contacts are open and easy to touch. To ensure high voltage safety through the entire sensor, we developed together with partners a connector that meets all the necessary safety requirements. This connector, shown on the slide, is designed with multiple coatings to perfectly fit CSM modules. It is type tested according to EN safety standards for up to 1000 volts DC working voltage. Additionally, it's water and fireproof, suitable for many mating cycles and much more. Please note, though, that the connector must only be assembled by trainee personnel. Each high voltage sensor cable undergoes a high voltage test, and we provide a high voltage certificate with every order. So let's have a look at our measurement chain again. Now the chain is high voltage safe, consisting of the cable and the connector. That's all from my side now. I will hand back over to you, Timo, to wrap things up and go on with the module.
Thank you, Kilian, for the detailed insights to high voltage safe cable and connector technology. Thank you. Well, as Kilian said, we now equipped our fixtures setup with high voltage safe sensors and cables and suitable connectors too. However, in this picture remains one huge uncertainty, and that is the standard measurement module. What's more, the high voltage safe connector of the SAB signal cable finds no match here at the standard module, and that for good reasons. Hence, that what we need is a suitable measurement module for measuring temperatures under high voltage conditions. And here we go. We see the high voltage version of this temperature measurement module, the HVTH Evo, here in the upper right, and its block diagram in the center. Well, imagine the temperature signal comes in, led by a SAB high voltage safe cable here from the left, and it's now fed into the high voltage part of our module. Now let's follow the signal path. We see a PT100 for the cold junction compensation needed where thermal material is connected to copper for accuracy enhancement reasons. We see a broken sensor detection, and we see an analog low pass filter. And now our signal is converted from analog to digital in this ADC here. And beyond that, that's the stage where the magic happens. The digital signal passes over to the low voltage part of the module, crossing our insulation barrier. With our signal crossing this barrier, we now can be sure that no high voltage potential remains to the signal, which is then fed into the microcontroller, processed, and sent on to the CAN bus via our CAN transceiver. Clean thing. And the left part of the circuit is implemented for every single channel that the module processes. So if we have 4 channels, 4 times this circuit here. Because every single channel has to be isolated from the others, because they are going to possibly lie on the most diverse high voltage potentials. So let's do a little bit of a study. Let's take a look at the term is isolation. The term of definition of isolation according to EN 61010 is found on this slide here, and it basically says that there's a basic isolation which is not sufficient for high voltage applications, and an additional isolation which backups the basic isolation, and there is a double isolation which consists of both of the first named. Well, we at CSM use a so-called reinforced insulation, which provides the same or better degree of protection as a double isolation, only its layers not testable individually, as it would be the case with a double isolation. Sounds complicated, right? Well, just recall, CSM high voltage modules comply 100% to EN 61010's safety requirements. Coming back to our example, we now see that we achieved to set up a totally high voltage safe temperature measurement chain, and in this manner we could now isolate every type of analog sensor. And in fact, as Kilian already mentioned today, CSM and SAB offer high voltage safe solutions for nearly every type of analog sensor you can find an overview on our website for this as well. But there's even more to this measurement technology safety concept. On this side here, you can find all the different type tests our CSM high voltage modules and high voltage cables of SAB undergo during their development. This includes type testing of the complete system, meaning the combination of modules and cables, and the modules and the cables each individually. And there's still more to this safety concept, because every single module and every single cable runs through a high voltage safety unit test in the production process and is always delivered with a test certificate. The cables of SAB, for example, are tested in the water bath during the production process, and additionally, the assembled cables with attached connectors are especially tested in a conductive ball bath, with every single cable receiving its own serial number. And for the CSM modules, let's also take a brief look at the unit safety test procedure. The EN 61010 demands that every high voltage module and cable delivered has to include a high voltage insulation test certificate. The test determines flashover strength between different potentials on the high voltage measuring device. So we built a test station at CSM which does the following. All measurement channels against each other and all the channels against the module housing are applied with 3100 volt DC testing voltage, performing a ramp from 0 to 3100 volts in 5 seconds and holding these 3100 volts for 5 seconds. And the result of the tests are documented in a test report, which you can here see on the right of the screen. And every high voltage safe measurement module that is shipped from CSM to our customers comes with this document. Well, coming to the end of our presentation, I want to briefly show you which further norms, standards, and guidelines could be relevant for you in case you work with high measurement technology in high voltage environments. And depending on in which country you work, they may not all be relevant for you. I won't read them all now here, because as a service you will have access to the slides, as I already mentioned, in our web seminar archive within the next hours, and then you can look up these things anytime you like. So if you are in charge of measurement tasks in electromobility, I would like to invite you to get in touch with our experts. Go onto our website and find the sales representative responsible for your region, give them a call or write them an email and discuss your high voltage applications with them. I'm 100% sure that it will be worth your time.